Today, we're diving into a topic that sounds like it's straight out of science fiction, but is actually shaping the future of technology. Quantum kinetics. It's a mind-bending field where quantum mechanics, the laws of heat, and statistics all collide. So, grab your thinking caps, because we're about to explore how the universe really works at its most fundamental level. First off, what does quantum kinetics even mean? Let's break it down. Kinetics is all about motion and change. How things move, react, and eventually settle into a state of balance or equilibrium. Think of how a hot cup of coffee gradually cools down to room temperature. That's kinetics in action. Now, add the word quantum. This tells us we're not talking about coffee cups anymore. We're talking about the bizarre and wonderful world of atoms and subatomic particles, where things can be in multiple places at once and can tunnel through solid barriers. So, quantum kinetics is the study of how these tiny quantum systems like electrons, photons, or atoms move, interact, and exchange energy over time, all while playing by the strange rules of quantum mechanics. It is what physicists use when the classical rules we learn in high school just don't cut it anymore. To really get a grip on this, we need to understand a few core ideas. One central tool is the quantum Boltzmann equation. It's like the ultimate traffic report for quantum particles, describing how their distribution changes as they zip around and collide with each other. Another key concept is the density matrix, which is a mathematical way to describe the statistical state of a quantum system. It helps us track how a whole collection of particles evolves over time, not just one. But perhaps the most fascinating idea is the dance between coherence and decoherence. Coherence is that special quantumness, the superposition and entanglement that make quantum mechanics so powerful. Decoherence is the process where the quantumness fades away, and the system starts to look and act like the classical world we're familiar with. Quantum kinetics is crucial for explaining exactly how and why this transition happens. It is the reason we don't see a cat that is both alive and dead in our everyday lives. So, where is all this theoretical stuff actually used? You'd be surprised. It's at the very heart of modern technology. In semiconductors and nanotechnology, quantum kinetics helps engineers model how electrons move through quantum dots and nanowires. It explains why your smartphone's transistors can be so incredibly small and efficient, thanks to a quantum effect called tunneling. In the world of quantum optics, it describes